Here we are once again, remaking another old video. The last time I made lightning, I was using modifiers. This time, I'll be using geometry nodes, and the results are going to be way better and much more realistic. I was actually planning on doing a different lightning video, like branching, arcing electricity, but it's taking me a little longer to finish, so I thought, oh, I'll just make a lightning strike first, it'll be quick and easy. Well, I fell down a rabbit hole when I found this slow motion footage, and felt like I had to recreate it and make it realistic. It took a while, but I did make sense of it, and I'll break it all down for you. I'm still going to make the arcing electricity video soon too, so subscribe if you don't want to miss that one. Also, if you don't want to make this yourself, you can get it on Gumroad for a few bucks, where I made everything organized and easy to use. My $10 tier on Patreon also has access to all of my Gumroad products, so you can get it there also, and end up saving some money if you plan on downloading a lot of those products. On Patreon, you can also find all the project files from my videos, and a bunch of other files that I don't share anywhere else. I also donate some of the profits to environmental causes each month. Links are in the description. Here's a quick summary of what I'll cover. We'll start with a basic curve, and with geometry nodes, we'll give it some thickness and distort it with some noise. We'll get the lightning strike effect with a trim curve node, and then we'll instance a bunch of other curves onto our first one, so it looks like branches. We want these to grow as our main bolt is growing, so we'll gather some information like how long our bolts are and where they start and end. Once this is working, we can turn it into a group to make as many layers of branches as we want. Then we'll make a switch, so when our lightning is at its maximum length, it'll make a flash of light and then fade away. When we do all that, we can draw our lightning into whatever shape we want and animate it super easily. Alright, let's get started. So here we are in Blender. I'm using the 3.1 beta. I believe most of this should work in 3.0, and if I notice any differences, I'll let you know what they are as we come across them. So to get started, we're just going to add in a curve. So I'll hit Shift A, add in a curve. We can use Bezier right here. I'm just going to make this straight up and down, about 2 meters tall. So I'm going to tab into edit mode, turn on snapping, and set this to absolute grid. And we'll just drag this up to that 2 meter mark, bring this one over to 0. I'll select everything with A and hit V to change both of these handles to vector type. And that should just make it straight up and down like that. So this is our curve. Now we can go into geometry nodes. So up here, if you don't have your geometry nodes workspace, go to General, and then Geometry Nodes right here. Our lightning is going to be vertical, so I'm going to reorganize this a little like that. And we can add a new Geometry Nodes modifier up here. By the way, if you tab into Edit Mode and you want to draw a curve, all you have to do is hit T to open up the side panel right here, or you can pull that arrow. And then there's this option right here for drawing, and it's really as easy as that. All you have to do is select that option. We'll do a little more of this at the end, but for now, I just want to work with a straight line. So first I want to give this some thickness, and that's pretty easy. We just use a curve to mesh node. So I'll hit Shift A, S to search, curve to mesh, put that right there. And for the profile curve, we'll use a circle, curve circle right here. And I'm just going to turn the resolution down all the way to 3. So this is basically just a triangle like that. And we can turn the radius down to something like 0.01. Also going to change the shading over here to cavity, select both, and I'll add a matte cap. I like that one. Okay, one other thing I like to do is add a set curve radius node right here. And we can change this with a, what's it called, spline length. So this is going to change the thickness of our bolt depending on how long it is. And you can see when we go into edit mode, when I pull this to make it longer, it will get thicker, and it'll also make smaller ones thinner. This will make a lot more sense once we start adding a bunch of branches. It gives it kind of like a natural thickness hierarchy. And if you want to adjust this, you can do that with a map range. And I usually just unclamp that. So if you want to prevent this from getting too thin, you can just change this to min value to something like 0.1 or 0.2, something like that. We'll come back to this a little later once we have more branches to work with. So I just want to group this together to make it nice and neat. I'm just going to select everything and hit Control J to add a frame. I'll hit F2 to name it, and I'll just call it thickness. So now I want to distort this a little. We can use a set position node, and we'll bring in a noise texture. And you can just plug the color directly into the offset. But for this to work properly, we need to add more resolution, because right now this just has 2 points. So I'll add in a resample curve right here. I want to change this from count to length. So this is just how far apart each point is. And I'll add a value node because we're going to be reusing this value a few times. So I'll put that right here and change this to 0.01. And now you can see it's distorting, but I want a little more control. So I'll add a vector math node right here, and we can set this to scale if we want. We can change how strong that distortion is, but you can see it drifting around. To avoid that, we'll add another one in here, set to subtract. We can just subtract it by 0.5, and now it shouldn't drift around anymore. This is a little too thick, so I'll just make it thinner over here, 0.5, something like that. I usually like to set the scale to something like 1, and I'll set the detail to something a little higher, like 10. So it just looks kind of jagged. One thing you might notice is that when we turn the scale up like this, the endpoints kind of drift away, especially if we change this to 4D, turn this up higher, and then we can move the W to make this like more random. The endpoints are drifting all over the place. And we don't really want this. We want to be able to control where it's actually going to strike. So to do that, right after our resample curve, I'll add a capture attribute, and we're going to capture something called the factor. We'll use the spline parameter. So if you're using 3.0, this will look a little different. I believe the node is called curve parameter, and that's how you get this factor. So we just plug this factor directly into the value right here, and then we'll use the attribute, and we just want to multiply that with our result over here. So we can change this to multiply and use the attribute right here, the factor. And now when we scale it up, you can see that this end is staying put. This one is still drifting away. So we need to change this a little. All we have to do is bring in a float curve right here. And we can bring this other one down all the way to 0 and make one in the middle. And I'll hold control while I'm moving this, and it'll kind of snap to clean numbers. And I'll just drag this up right here and leave it right in the middle. So now both ends should stay put. So what the factor does is it finds the beginning and the end of a curve. So at the beginning, it'll have a value of 0, and at the end, it'll have a value of 1, and every point in between is interpolated and smoothed out. So after this, we can add a trim curve node right here. And this is how we're going to control our lightning striking animation with just this end slider right here. So the reason we're using this capture attribute right here is because we want the factor to be measured before it's trimmed like that. Because if we capture it after it's trimmed, it's going to give us a different result like this. So make sure you're using the capture attribute right here for that factor, and that it's before the trim curve. Now I'll just put these in a frame, select all of them, hit Control J, and I'll rename this Distortion. All right, for this next part, I'm just gonna turn the distortion down to 0 so we are working with a straight line again, because it'll be easier to see. So after our trim curve, we're going to use an instance on points, and this will immediately disappear. So we just need to add a join geometry. And we want to join these instances with our original geometry over here. And what we want to instance is just a curve line right here. So we can instance like that. And it's a little hard to tell until we rotate it. To get these to rotate correctly, I'll just use the curve tangent right here. And we'll use an align Euler to vector. We want to plug the tangent into the vector and plug the rotation into the rotation right here. I'll set this to Z, which might seem a little counterproductive, but when I was testing it out, this looked better when you set it to Z, and then you can use a rotate Euler right here, and you can adjust your rotation over here like this. So we can set this to 90 if we want it straight out like that. And if you want these to be shorter lines, you can just change the value of this endpoint right here for your curve. So we also want this to spin around like this, kind of randomly. First of all, we're going to need a combine XYZ, because right now we only have one plug right here, and I want a plug for each channel like that. And one thing that's kind of weird is the combine XYZ doesn't use degrees like this does. It uses something else called radians. So these values are going to be a little different. If you want the Y to be at 90 degrees, you can eyeball it and just get it close, or you can do pi divided by 2, and that will be exactly 90 degrees like that. So we want to adjust the Z value right here, and I'm going to give that a random value with a white noise node. So you would think you could use a random value node instead, and in most cases you would be right, but the white noise texture works a lot better, especially when you're trying to keep everything consistent while making it grow. So we're not going to use this random value, we're going to use the noise texture right here. And you can just plug that in, and immediately you'll see that it's starting to change the values. But we want to remap these. We can do that with a map range. I believe this is one thing that's different in 3.0. The map range in 3.1 allows you to change it to vector, and I think that's not in 3.0. I like using the vector for this because if you plug the color in here, then you actually get 3 separate white noise textures that are a little different. So the values you want to change to remap are just the 2 min and 2 max right here. And I'll add a separate XYZ right here so we can actually separate each channel. So we can plug the Z into the Z right here, and we just have to adjust these values right here. So if you want to change this to like 360 degrees, that would be pi times 2, or something called tau, which is just pi times 2. If you don't want to do that, you can just round up to 7, and it'll be just as random. And for the 2 min, I can set this to -7 right here. Once again, make sure you're putting these in the Z channels right here, this third row. If you want, you could do the same thing for the Y value right here. You just plug the Y into the Y. Usually I like to just play with these values right here and see like how far I want it to go. So I could do like 1.5 to maybe like 0.7 or something like that. 1.5 and 0.7 right here, and then plug this in, and it will be a little more random for you. When we turn our resolution up, you can see there are a whole lot of branches, and it might just get a little too crazy. So to change how many there are, you can use the selection right here. So for the selection value, I'm gonna use the white noise texture also, but I'm gonna use a math node set to less than, and I'll plug the color into there. You can use the value also if you want, and then I'll plug that into the selection. Now you can control how many branches there are by turning this up or down. So I usually leave this around like 0.25. So about a quarter of them are there for this resolution. When we try to distort this, these don't actually distort, and that's because, once again, we need to change the resolution of these. So we can do that pretty easily, basically the same way we did over here with a resample curve, but this won't work until we realize the instances. This just makes them like real geometry. And once we do that, we start getting some distortion. And we can change this from count to length, just like we did with the first one. And we can reuse this value over here, just drag it all the way over. And now this will have the same resolution as our parent curve. And that's how you get the distortion. Let's just turn this back down. So the next problem we run into is when we change the length right here with this trim curve. You can see this just kind of like blink in and out of existence like that. And I want this to look more like it's growing. So what we need to know is where our parent curve is starting and ending, but we need that value after it's being trimmed. So right now we do have that, but we have it before it's being trimmed. So this is like where it will end up when it's completely full. So I'll just duplicate that, place it right here, and we can plug the factor in right there. And now this value should give us the same thing, but after it's trimmed. Now we just have to bring in another trim curve right here, and we should be able to plug that directly into the end slot right there. So this is close, but it looks like it's inverted. So instead of it being long at this end and short at this end, I want it to be flipped around. So I know the factor puts out a range between 0 and 1. So to invert that, we can just bring in a math node set to subtract. I'll just place it right here, and we can just subtract it from 1. And this should work as long as you know the values are between 0 and 1. So let's take a look at this now. So this is working pretty well. If you pay attention to these lines right at the top, once they start growing, they grow really fast, and then they get really slow like that. So it kind of like smooths to a stop. And that might be fine for you. Like, I don't think it looks bad, but I kind of want all of our curves to grow like at the same rate. So to do that, we're going to need a few more values. We're going to need to know the length of our parent curve, like our the maximum length that it can be. And we need to compare that to how big it is while it's growing. So we can do that with some more capture attribute nodes. Basically, we can just duplicate this, put it right here. I'll put one after right here also. And I'm going to bring in another node called spline length right here. And this is different from this length right here. This one will output, I believe, like a single value. It'll just measure this exactly to see how long it is in meters. So we can plug this length into here, and we can also plug it into there. So this is giving us our maximum length of the curve, and this is the curve like as it's growing. And if we bring in a math node set to divide, we can get a ratio out of this. So we just want to put this one on the bottom and this one on the top. I'll bring this divide node over here, and we just want to multiply these together. And now all of these should grow at the same speed. This is a completely optional step. I just like the way it looks when it's growing in this kind of linear way. So I want to make a third layer of branches that are coming off of these branches right here. So right here we have our main branch, and all of this is the secondary branches right here. So I'm just going to group all of these together. I'm just going to hit C to circle select, and I'm just going to grab all of these right here. I like to just move this around with G to see if I'm missing everything. It looks like we got everything. I'm actually going to leave the noise on the outside, and then I'm going to hit Control G, and that should group everything right there. Now we just have to clean this up a little. So we can change the name of all this and reorganize it by hitting N while hovering over here, and it'll open up the side panel. You can go to Group, and you can change all the names in here if you want. So points, I'm going to move that to the top. I'm going to call that curve, and I'll rename this curve also. Length should be resolution. I'm also going to duplicate this just to bring it closer to certain places to make it cleaner. So this is our factor, our length, and our max length. And this vector right here is our noise texture. So I'll just name that noise. I want to be able to change the length of these from the outside. So I'll add a combine XYZ right here, plug that in, change this to 1, and this will be our branch length. Now I'm going to want to reuse some of these values. If we tab out, I want some of these values to be on the other side also to output. So I'll just duplicate the input right here, and I can feed some of these to the other side, like the resolution and the noise and the branch length, like that. If we want the third layer of branches over here, we're going to need pretty much all of these values on the other side to feed into a second one right here. Go back inside here, and let's see what we have. We need the factor. Oh, actually, I don't want the join geometry in here, so I'll remove that and plug the curve back in right here. And I want the join geometry to be on the outside right here. So I'll just bring everything closer. We can plug that in right there. So I know the factor should be after the trim curve because we're looking for the factor as it grows. So I can do the same thing we did before with the capture attribute right here. Bring in the spline parameter and plug the factor in right here. And I'll just grab this and plug it in here just so we get the name. And then I'll replace it with this attribute like that. So we have our factor now. And I just want all of these to be in the same order as up here. So I'll put this below the resolution. We also want the length and the maximum length. So once again, the maximum length is going to be before the trim curve right here. And the length is going to be after the trim curve. Bring in the spline length right here. We can just plug it in. We can just plug it in right here and also over here. Length and max length. So I think we have all of the values that we need now. So we can just plug the curve into the curve and basically just plug all of these in. So I believe this is a node wrangler thing. If you select both of these and hit F, they'll just start plugging each other in like that. And now you just have to join this curve into the join geometry. And we should have branches coming off of our secondary branches like that. And if you want to change the branch length, that's this option right here. I want each layer of branches to be a little smaller than the next one. So we can come in here and add a new value. I want this to be like a branch multiple. So I'll add a math node set to multiply, and we can plug this into there, and I'll call that branch length multiple. And I just want to plug this in over here. And I don't want our branch length to be plugged in like that. I want to grab the value that's coming out of this multiplication node, just drag it over here like that. So if we have this set to 0.5, it's going to make each layer of branches half the length of its parent, if that makes any sense. I want a few more options like this value right here, the threshold, and we can plug that in over here also. We can also add some random branch length to this so it's not as like regular, and we can do that by multiplying this once again right here with a noise value. So I'll just use the X from our noise texture over here and plug that into the multiplication, and this will make it a little more random. So on the outside of our group nodes, if we want to change where the branches are, all we have to do is switch the noise texture to 4D, and then we have this W value. And that's like a random seed that will place the branches in different areas like that. So here's one issue that you might run into. You can see at the tip right here, this is very straight, and that's just going to happen at the very ends, at the very tips right there. So one thing I like to do is make it so that we don't get any branches too close to either end. We can do that by altering this selection right here. And right now we're using that white noise texture to change this. So we can find the endpoints pretty easily because there's a node called Endpoint Selection. And if we plug this directly in, you can see it only selects the endpoints. And we can turn this up to select, however many points we want from either end. So we want this to be inverted. So instead of plugging that in directly, we just need a Boolean math, and we can turn this around by changing this to not. Now it will select everything except for the ends. So we can mix this with the selection we had before with another Boolean math right here. I'll change this to and. So now we shouldn't get any points on the very end. And I'll just turn this up to something like 5, just so we don't get any that are like too close to the end, like that. And I'll just shrink all of these down by highlighting them and hitting H to hide. We can make this a little smaller. All right, so now that we have this, you can add as many layers as you want. If you add too many layers, it will start to slow down quite a bit. But all you have to do is make another group and then plug all of these in right here. Just make sure that all of the curves are being joined together like that, and you shouldn't run into any problems as long as you followed all this correctly. If anything looks like it's not right, you might have to switch around some of the values. Like this looks like it's spawning in at the wrong time, and that's because the length and the max length are flipped in the wrong spot. So I'll plug this back in up here, and now it's working properly. It's easy for this to get really messy really quickly, so stay as organized as possible, and if anything is going wrong, just make sure that everything is plugged in correctly. Before we get the animation and shading worked out, let's talk about our sponsor, Sketchfab. Sketchfab is an online marketplace where you can buy and sell 3D models. Sketchfab allows you to inspect and interact with models directly in the browser, so you know exactly what you're getting. If you're interested in modeling challenges, they have one that just started called Villain's Lair, where you're prompted to create a space where evil plans are hatched and devious plots are set in motion. If you place in the top 3, you get some prizes. So first place gets a $2,000 cash prize and a bunch of other stuff that when combined equals nearly a $3,400 value. You have until March 28th to upload your scene to Sketchfab with the hashtag Villain's Lair Challenge. For all the details, you can click in the link in my description. All right, let's move on to the animation and shading. So what I want to happen is when this reaches its maximum length, we have like a flash of light and then it fades away. What I'll do is plug the group input over here into the end, and that will give us this end value right here that we can play with. Hover over here and hit N. In the side panel, we can click on that. Right now, the maximum goes up to 1, which makes sense because the maximum over here is 1. We can actually change this to something higher, like 2. And when we turn this up higher, it won't allow us to turn this up higher, but we can use the extra space after to make some things happen. So this next part, we're going to be jumping between the shading workspace and the geometry nodes workspace quite a bit. So to get started, I'll just find this factor right here, and I'm just going to plug this way over here into the group output right here. And this is a way we can capture an attribute coming out that we can use for like our materials. So I'll just hit N. I just want to name this to material factor. And then we just want to write something in here that we can reference in our shading workspace. So I'll just name this factor. And I believe this is case sensitive, so I'm using a capital F. Just remember that. And we want to give our lightning a material so that we can actually test this out. So bring in a set material right here, place it at the very end, and we just need to add a new material over here. You can name this whatever you want. I'll name it lightning, and we just want to assign it over here. And now we can go up to our shading workspace over here. I'm just going to delete this principled shader right here, and we're going to replace it with an emission. You can just plug that into the surface. And we're going to bring in an attribute node. And for the name, we just want to put the name that we gave our material factor over here. So I know this is factor with a capital F. And now we can take a look at this by plugging it into the color. And this is what it's outputting for us right here. So it's allowing us to see where the beginning and end of our lightning bolt is, like that. This is going from 0 to 1, and then in the middle at 1, it should stop. and just stay the same beyond that point. All right, let's go back to our geometry nodes workspace to finish setting this up. So I want this factor value for each different branch segment. So I'm just gonna bring this over here, and I'm gonna add up all of the factors. So I'll bring in a math node set to add right here, grab the factor right there, and I'm just gonna add up all of the factors. So just keep grabbing the factor and adding them together like this. And if you want, you can see each of these individually by just, disconnecting them like that. So this is only like the third level of branches, or I guess it would be the fourth if you count the main branch or whatever. And instead of plugging this into the color, I'll plug it into the strength so we can control how bright it's going to get. So after all of these are added up, we can put a switch node right here. You just want to set this to float or else it won't work. So I'll change this to float and plug it back in. So this toggle will allow us to switch between what we're seeing now or whatever we plug into this second slot right here. So if we switch this over, this is how we're going to control how bright it gets. So we can just set this to something high like 50, and this will allow us to switch between them. So I'm just gonna grab one of these group inputs, duplicate it, and then bring it a little closer. And we're gonna flip this switch with this end value right here. Once again, it's this over here. So I wanna say when this value is greater than 1 to flip the switch right here. So we can use a compare node right here. And this is already set to greater than. So we just plug the end in right here and change this to 1. So when it's greater than 1, flip this switch. That's basically what it's saying. So nothing should happen when this is at 1, only when it's greater, like that. So from 0 to 1, I want it to grow. Then right after 1, I want it to flash. And then on its way to 2, I want it to fade out. So to get it to fade out, I want to kind of change this 1 to 2 range to go from 0 to 1, if that makes any sense. To do that, we'll start with 1 and turn that into 0. So take a math node, take the end, and we'll just subtract it by 1. So now we should have a value of 0. Now we want to invert this, put a 1 on the top, and plug this into the bottom. And now we can plug it into the true value over here. So now when this goes from 1 to 2, these two nodes are making the value change from 1 to 0. So it should fade out like that. 0 is shown as black, so that's why it's turning black. To make it flash bright again, we can just put a multiply node right here and just turn this up as high as we want. So I'll set this to 50 again. So this should flash now and then fade out like that. So now that we have this, we can set up our shaders. So let's go back into the shading area. And when this is black, I want it to be transparent. So we can bring in a mix shader right here, and we can just plug the color into the factor right there and plug the shader into the surface. So when this is black or 0, I want this to be transparent. So we'll bring in a transparent node right here, plug this into the first slot, and an emission into the second. So if you're using Eevee, this isn't going to work just yet. You have to go over here to material properties, and under settings, change the blend mode from opaque to alpha blend like that. I'm also going to change the shadow mode to none so that it has no shadow. And now the transparency should work just fine. It looks like it's broken, and I think that's because this factor expects a value between 0 and 1. But because of the way we set it up, as soon as it passes 1, it's given a value of 50. So we need to clamp this. We can bring in a clamp node right here. This should make it so it doesn't let it go past 1. We can just plug this color into the strength also, and that will allow it to bloom again. So now it should grow, it gets bright, and then it fades out like that. One thing I like to do is try to make the ends look a little brighter. So to do that, we can just add some more math nodes. I'll just add a power node, change this to power, and I'll put one before all of our add nodes up here like that. And we can have these share the same value by using a value node and plugging them all in over here. We should probably put one right here too for our main branch. So it's just pushing all the bright spots to the end right there. And I think that's a pretty cool looking result. So I'll just set this to something higher for these branches, like maybe like 10. And I'll set this one for the main branch to 0.5. We can go back over to the shading tab. We can change how this is distributed a little better with another math node, change it to power, and add another one. We're just going to change this to add, and we're just going to add these together And when you turn this up, it'll make all of the bright spots be pushed towards like the very edge, like that. And the maximum brightness is over in geometry nodes at this multiply node in the end. So if you push this a little further, this is like how bright it's getting. So we can turn this down a little because it's getting really bright. And I'll maybe turn this down a little lower. I like the end points to be kind of bright. The end, like leading points like that being bright is kind of how it looked in the reference that I was looking at. I thought that was a nice touch. I think this looks nice when you set it to be like a blue color like this, but you can set it to whatever color you want. Another thing that you can do is instead of this just fading in and out, you can add a texture. So the way that I like to do that is with another math node. We can change this, I believe, to less than. And I'll bring in a Voronoi texture right here. And I just want to use object texture coordinates for this. So I'll add in a texture coordinate node and plug object into the vector. And we can plug the distance into the threshold right here. I want to plug the color into the value. We can basically use this instead of our clamp. Just plug this in right here. And I think what we have to do is just turn this up a lot higher for it to look right. I think this is going in the wrong direction, so we can change this to greater than. And now you can see when it fades out at the end, it kind of does this dissolve instead, like that, with a bunch of little dots. And I think that looks pretty cool. So if you want these to be a different size, you just want to change this texture to be as high as you want, really. Another thing that happens in the reference is that when it actually strikes, all of the branches disappear except for the one that actually makes contact. So we can do that again with another switch. So I'll just duplicate this and bring it up right here. I just want to change this to geometry. So I'll just flip this around and set this to true. And basically, instead of joining all of these together, you can just take the main branch, this main branch over here, and just plug it into one slot right there. And that's how you get rid of all of those branches. So we can use the same switch that we used right here. So when this is greater than 1, you just want to flip that switch. So we can just take this greater than, drag it all the way up here to use as the switch. And it looks like we need to flip these around. I'll just plug this in right here. So now it should grow, and as soon as it strikes, all of those branches disappear like that. This step is completely optional. You might think it looks better when it flashes and all of those are here. So if you don't want to do this, you don't have to. You can also just come over here and press M to mute it like that, and that'll just kind of shut it off for you. So now we can animate this really easily. I'll just pull up a timeline over here. Switch over to timeline, and on our first frame, I'll hover over this, hit I to insert a keyframe. I'll go to frame like 60, turn this all the way up, and then insert another keyframe. And if you select this, select the keyframes over here and hit T and change this interpolation to linear. And I'm also going to change the endpoint to 60 right here. And I want our frame rate to be 30 frames per second. So that's our animation right there. And once again, if you want those branches to stay at the end, all you have to do is mute this switch right here, or you can add another switch in here. But I'm not going to do that in this video. I did do that for the final product, as well as like plugging a whole bunch of things into the group input right here so you can control it from the outside. So if you did want to do that, you can basically just take this group input, duplicate it all over wherever you need it to be, and you can just plug this in like that. So now we have the resolution in the side. So I like to use this especially for the threshold right here, or the, like the branch probability. This comes in handy when you're duplicating this all around and stuff like that. So I'll add this for like a few of these options over here. And now if we want, we can just go into edit mode, open up this side panel with T, and we can draw whatever shapes we want. And this is already animated too, so I'll just delete this and just draw a branch like that. I think the branches should be a little longer, so looks like this is the multiple on top. So I'll change the branch length right here. You can change the seed if we want it to be something a little different. I think that looks pretty cool. That's all there is to it. If you wanted these bolts to be rounder at the end, you can just come over here to your thickness right here. And what I would do is just add a math node in here set to multiplication, and you can just use the factor from the first curve, is this one right here. Just drag that over like that. That will make it so it's thick at one end, and then we can do the same thing that we did right here with the float curve. Bring a float curve in, plug that into the value, then into there, and you can adjust this however you want. So if you want it to be thick in the middle, you could totally do that. What I like to do is just push this really close to the edge, just so that it rounds off a little at the ends. Because without this multiplication node, the edges look a lot harder like that. All right, that's it for this one. Once again, you can get this lightning generator on Gumroad or Patreon. And if you'd like to check out Sketchfab, all the links are down below. I'd like to thank my patrons for their support, and I'd like to thank you for watching. Have a good one.